In section 9.2, we're talking about the multiplication principle, permutations, and combinations. And we're going to talk about the differences between permutation and combination towards the end of the lesson. In section 9.2, we need to understand the multiplication principle. This is what it says in your book on the definition of the multiplication principle. And I'm actually going to use an example that they have in your book on the road. So in your book it lists, we have town A, and to town A, or excuse me, from town A, we can go on 3 different roads to town B. From there, we could take 2 different roads to town C. And what we want to know is we want to know how to calculate how many options we have for traveling from town A to town C, that as long as we have to go through B. So we would say, well, we have the first option where we go the first road, and that's what you can see here. We have that first road here, first road here. We could take the first road but then take the second road. Then we could take the second and first, second and second, third and first, and third and second. So you can see here we had 6 different routes that we would take. According to our multiplication principle, all we have to do to be able to find the number of choices that we would have is to multiply our number of options together. So to go from A to B, we have 3 separate options. To go to town C, we have 2 separate options. 3 times 2 gives us those 6 choices. So we're going to look at a couple examples. Suppose Angela has 9 skirts, 8 blouses, and 13 pairs of shoes. If Angela is willing to wear any combination, how many different skirt, blouse, and shoe choices does she have? Well, we just want to find out how many possible combinations we could have. So we have 9 shirt options, 8 blouse options, and 13 shoe options. So in order to get the number of combinations without having to make a tree like we did before, all we have to do is multiply those 3 values together. So I'm going to do that in my calculator. 9 times 8 times 13. And we get 936. So that's how many different options we have to choose that to make an outfit. We're going to try some examples from the book. These are on page 557. The shoe example is actually in the book. It's one of your examples. It's example 1. We're going to do these from the homework section. Number 24 says how many different heating cooling units are possible if a homeowner has 3 choices of efficiency rating and 3 options for the fan speed and 6 options for the condenser. Well, how many different heating and cooling units are possible would take, according to our multiplication principle, our 3 choices for efficiency times our 3 options for fan speed times our 6 options for the condenser 3 times 3 is 9, times 6 is 54. So we would have 54 different possible units. All right, let's look at number 26. This one is a double part here. Okay. On 26, we're going to look at option A first. Oops, sorry. Close that out. Option A says if the first letter must be a K or W and no letter may be repeated. We're talking about how many different four-letter radio station call letters can be made. So if you've ever listened to the radio, usually they'll have the name of it like KYFO, or you might have even seen the news stations like KLBK, things like that. So what we're asked to do is have 4 different letters. So we have 4 different positions, and we're told that the first letter has to be a K or W. So if it has to be a K or W, there are only 2 choices for that first position, only a K or W. In no letter can be repeated, that's the same thing as saying when we calculate probabilities of drawing a card without replacement. So if I've drawn that K or W, there are only 25 letters left in the alphabet. After I've drawn that letter, there are only 24. And after I've drawn that letter, there are only 23. So now I need to multiply those together. So let's go to our calculator. 2 times 25 times 24 times 23. Enter. And I get 27,600 different combinations. Right, let's look at answer choice, let's look at answer B. So if repeats are allowed, but the first letter must still be a K or W. So let's talk about how this changes our positions. So we still have our 4 options. So 1, 2, 3, 4. The first one still has to be a K or W. So we still have our 2 positions there. Now we have 25 left. Well, actually, since repeats are allowed, we still have 26 left because we could repeat that K or W. We also have 26 left and 26 left. So what I really have is 2 times 26 cubed. So I'm going to put that in my calculator. 2 times 26 cubed. So I have 35,152. Okay, we're going to try part C now. Part C asks how many of the 4-letter call letters starting with K or W with no repeats ending in R. So we have our 4 positions. We know we have 2 choices here and only 1 choice at the end because we want it to have an R. So after we've chosen our K and W, we have 25 letters left, but after we've chosen our R at the end, we only have 24 and 23. So 2 times 1 is 2, but 2 times 24 is 48. So we have 48 times 23, and I get 1,104. Notice when we have to fix positions like this, it reduces the amount of combinations that are possible. When we have more options for each space, notice how our number of combinations increases. Okay, let's try 28. It says the United States Postal Service currently uses 5-digit zip codes in most areas. How many zip codes are possible if there are no restrictions on the digits used? Okay, so how many possible zip codes are there? Well, we have 5 digits, and any of those could be 0 through 9. So that means there are 10 options in the first, and it says that there are no restrictions on the digits, so there are still 10 available, which means we can repeat those numbers. So this is just 10 to the 5th, which is 10 times 10 times 10 times 10 times 10. And notice we get 10,000. So there are 10,000 different opportunities. So now let's look at the second question that it asks. It says, how many would be possible if the first number could not be a 0? Well, then we look at the first position and we say it can't be a 0, so there are only 9 options for that first one. But we still have 10 options for the other 4. So I have 9 times 10 to the 4th. And so I get 90,000. And I happen to think I'm missing a 0. Sorry, I missed a 0 on that first one. Should have been 100,000. Alright, so we have those different combinations there. Alright, now we're going to introduce the concept of a factorial. A factorial is just a math notation where we are multiplying in sequential order, but in a descending pattern. Now we have in factorial, that exclamation point is the factorial part. So when we have in factorial, it's n times n minus 1 times n minus 2, all the way until we get to 1. By definition, our 0 factorial is equal to 1. And this kind of makes sense when we talk about raising things to the 0 power and things like that, where 0 factorial equals 1. And there's an example in your homework, number 21, that you're going to look at, kind of going further into why 0 factorial has to be equal to 1. But the factorial is useful for when we are looking at combinations where we have to restrict repeating and where order would matter. So notice we have this question here. How many ways can 6 executives line up their golf carts at the country club? So we would have 6 people lining up golf carts. So those are 6 distinct golf carts. So if we were to use our counting principle or our multiplication principle, we would say we have 6 choices for the first, but then we've used up one of those, so we only have 5 choices for the second, and so on, and so forth. So 6 times 5 times 4 times 3 times 2 times 1 is actually what we call 6 factorial. So 6 factorial is how we would get this answer. So we would multiply 6 times 5 times 3 times 4 times 2 times 1. And we get 720. So there are 720 different combinations. How many different seating arrangements can be made for a class of 24 students? That means we have 24 different positions in a class, and we want to know how many arrangements are possible. Well, that would be like saying if I've chosen one child in the first seat, I would have had 24 students to choose from. Once I've chosen a student to put in a chair, I only have 23. Once I've chosen a student for that second position, I only have 22 left. So on and so forth, where I multiplied by 1 at the end. This is what 24 factorial is. Now, without having to enter 24 times 23 times 22 all the way in our calculator, we actually do have a factorial button. Now, I'm using an 84 emulator, but it should be the same buttons on the 83. So if you go to Math and all the way over to the probability option, notice you have that exclamation point. That is your factorial. So if I were to quit and type in 24, Math, all the way over, and choose option 4, enter, notice I get a really, really big number. So you can see how to calculate the factorial with your calculator. Now we're going to try some examples of this. We're going to do numbers 2, 4, and 7. We're going to come back and do other examples later. Right now you don't know what 4p2 means. We'll come back to that. Right now I'm going to look at number 2 for 3 factorial. So I can calculate that by hand. That's just 3 times 2 times 1, which is 6. 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so 7 Math all the way over, choose option 4, enter, and I get 5,040. Number 7 is 4 factorial. That's a rather simple one, so we'll just do that one by hand. 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24. So you can see here, calculating those factorials, all you're doing is starting with the value that they give you, and then multiplying by each number, each integer below that, until we get to 1. Okay, so here's a practice problem. A pharmaceutical salesperson has 6 doctors' offices to call on. In how many ways can she arrange her schedule if she calls on all 6 offices? That means we have 6 positions to place. So I would have 6 times 4, 6 times 5 times 4 times 3 times 2 times 1. How many ways can she arrange those calls? Well, we have 6 options for the first position. Once we've used up that option, we have 5 left, and so on and so forth. So we would then do 6 factorial in our calculator. And I get 720. We found that earlier. Now for part B. In how many ways can she arrange her schedule if she decides to call on only 4 of the offices? So instead of having 6 positions for all 6 offices, we only have 4 positions to place here. So we have 6 options in the first, 5 in the second, 4 in the third, and 3 options left for this one. Notice we can't add that 2 and 1 on the end because we're only calling 4 of those. So 6 times 5 times 4 times 3. So we really have 6 times 5 is 30. 4 times 3 is 12. So we have 30 times 12. So we have 360. So notice reducing the amount of positions reduced our space by half. Alright, so now we're going to talk about what a permutation is. A permutation is an arrangement. It's where we place a number in a position purposefully. So I have a set number of things that I'm placing, and order is going to be important. So we're going to figure out how to calculate a permutation. We have this formula here. So you need to notice the notation. The notation is small n, p, and then r. N is the number of elements, and r is a rate of time usually. So we have an permutation of n given r. So we would say the n factorial over n minus r factorial is going to be the number of permutations with n elements. So that means that the n are our choices, and r is how many places we have. So this is like saying our 6 doctor's offices, and we only chose 4 of them. Notice that the n minus r is in parentheses. So, going to use my formula here. I want to calculate permutation of 8 given 5. What that means is that I have 8 options but only 5 positions. So what I'm doing is I have n factorial. N is going to be 8 and r is the 5. All right, let me take a picture of this. Okay, the reason is so I can have the formula on this page without having to go back and forth. Now, n factorial is going to be 8 factorial. So that means I'm going to have 8 factorial over, now notice the n minus r is in parentheses. So 8 minus 5 gives me 3 factorial. Now let's look at what this means. This means I have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. Notice what's going to happen. Because I'm multiplying, I'm going to be able to reduce out my 3, 2, and 1 from both the numerator and denominator. So I only have 8, 7, 6, 5, and 4 left, which is what we would get if, just like we did those positions, here we only multiplied 6 times 5 times 4 times 3. We got rid of the 2 and 1 as options. So that's the same thing we're doing here. We have our 5 positions, but now we have a formula that we can just use to calculate it. So you can actually put this in your calculator, 8 times 7 times 6 times 5 times 4. And I get 6720. You can also do these in your calculator. If you go to Math and scroll over all the way, notice you have NPR as your second option. Now, the way to type this in is you're going to have to type in the first number, so type in your N, then go to Math, option 2, and then type in your second number. And we get this for the option of 25 given 5 positions. So we also can use our factorial notation. So I could have used the formula here and said, well, this should be 25 factorial divided by 25 minus 5 factorial, which is 20 factorial. And we would have gotten the same answer. Alright, we're going to do some of these examples. Let me add a new page, and here we go. So we're going to do 1, 5, and 8. So 1 is 4p2. That means that we're going to have 4 factorial over 4 minus 2 factorial. 4 factorial is going to be 4 times 3 times 2 times 1. 2 factorial is 2 times 1. Those will go away. So I'm just left with 12. Number 5, I have 8p1. That's 8 factorial divided by 8 minus 1 factorial. So 8 factorial divided by 7 factorial, you should be able to see right away what's going to cancel out. My 7, 6, 5, 4, 3, 2, and 1 all cancel, so I know that 8p1 is going to just be 8. Right, a number let's do number 8, 4p4. This is 4 factorial divided by 4 minus 4 factorial, which is 0 factorial. But remember, by definition, 0 factorial is just 1. So this is really 4 factorial over 1, which is really just 4 factorial. So 4 factorial is 4 times 3 times 2 times 1, which is going to be 24. Alright, we're going to practice a little bit of doing this in the calculator. So, to type this in your calculator, we're just going to do numbers 13 and 14. So you have to type in your in value first. We've already done 13, so I'm going to not do that again. Let's do 14. So type in 40, go to math, all the way over, and choose your permutation. It's 40 given 5, so once you've typed that in, type your 5, and you get this very large value. Okay, try number 15. We have 14 math 2 given 5, enter. 240,240. Alright, moving on. Now we're going to talk about combinations. Combinations are just groups of things. So here, order is not important. So we have a different formula for that. We have n factorial over n minus r factorial times r factorial. Well, if you remember from just a little bit ago, our permutation was n factorial over n minus r factorial. So this piece of our formula right here is our permutation. And they actually go through in the book and show you how the two are related. Now, so another way you could think about this is it's actually NPR divided by R factorial. So if you've calculated your permutations, all you have to do is divide by the number of positions factorial. Okay, so let's try some. We're going to try by hand to first set up this problem up top. How many ways can a jury of 12 people be chosen from a pool of 48 people? Well, the number of options is n. The number of people are the number of our options, so 48 is n. And 12 people are the ones that are going to be on the jury. Those are the amount of positions that we have available. So the way we would set that up is 48 C12. Now, by hand, the way to do this. So you have to remember your formula. N factorial over n minus r is 7 factorial times r factorial, which is 3 factorial. So we're going to have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we have 7 factorial, which means we'll have 7 times 6 5, 4, 3, 2, 1 times 3, 2, 1 for the 3 factorial. Notice we can actually cancel out the 7 factorial. So all we're left with is 10 times 9 times 8 divided by 3 times 2 times 1. So you can put that in your calculator. You have 10 times 9 times 8. Then you have 3 times 2 times 1 is 6. So we're dividing this by 6. Enter. So we have 120. Alright, the way we enter this in the calculator is the same way, except we're choosing a different option. So I have to enter the 32 first, then go to Math, over to Probability, and choose in CR this time. Now type in the R value, and that's my answer. Alright, I'm only going to do a couple of these. I'm going to do number 6. So number 6, we have C72. So that means we have 7 factorial divided by 7 minus 2 is 5 factorial times 2 factorial. Now, you can actually put this in your calculator as the factorial notation. So I can put in 7 math over choose 4. And I can divide that by 5 factorial times 2 factorial. And I get 21. Okay, again putting this in the calculator as using the combination. You have to type in the first number, or type in your in value first. So I'm going to do number 19. So you type in 28, go over to Math, over to Probability, option 3, and then type in your second number, which is 14. And we get this big, large number, 40,116,600. Okay, now let's make the distinction between permutation and combination. Permutation is in place R. That's going to mean that order matters. A combination is where you're choosing that option. So order does not matter. Another way to think about this is when we talked about number sets and whether sets were equal or not. In a permutation setting, where order matters, that would mean that the set 1, 2 is not the same as 2, 1. Those would be two distinct elements or two distinct sets because order would matter. So it would make a difference whether the 1 came first. For a combination, we would have the set 1, 2 and the set 2, 1, and those would be equal. So this is the main distinction between the two. For a permutation, order matters. For a combination, order does not matter. So when you're doing your work, your problems on your homework, you need to pay attention to whether it implies that order matters or not. Alright, here's your assignment for section 9.2.